All right, so in this topic, we're going to talk about zeros of functions. And, well, let's ask the question first. Well, what is a zero of a function? Well, what is a function first? A function can be some arbitrary curve on a graph. We can draw a curve like this, okay? And we want to know what the zeros are. Now, basically, the name zero, just comes for whenever the y value of a function is zero. And that means when the y value is zero, it's when your function crosses the x-axis. Because over here at this point, I'm going to point an arrow at this particular point, for example, there's no y value here, right? We're going a distance, let's say on our x-axis, we're going a distance negative x somewhere over here between -8 and -10, at least that we know of. But the y value, there's no y value right here because we can see that this function is crossing the x-axis, and then right when it's crossing the x-axis, the y value is 0. So that's what we mean by zeros of a function. Now let's go ahead and pinpoint all the zeros of this arbitrary function that I just went ahead and drew. So there's a point right there, and then there's a point right there, and then there are 2 points that I already circled right here. So these are zeros of a function. And that's what it looks like on a graph. Now, how can we write this in an equation? So it's whenever, remember we said when the y value is equal to 0. Okay? So this is the key thing that we need to know here. It's when the y value is equal to 0. Or we could say when f of x, this is a function that we plot on the graph, is equal to 0. All right. So let's go ahead. Let's look at an example really quick. So here is an example of a function p right over here. This is our function p. And we want to know where the y value is 0. When does it cross the x-axis, in other words? So over here, we can see 3 points. You should be able to see right away that it crosses through the x-axis at 3 locations here. And I'll go ahead and circle those, or put a dot right there. So it's when, let's see. So let's look at this point first. So this point, it's in between -2 and -3. So where does that lie? It's halfway, we'll assume it's halfway in between. So it's about -2.5. Or we could say, if we want to write it in a fraction, it's when x is equal to negative, and let me draw a better negative here. It's when x is -5/2. That's the equivalent fraction of 2.5, right? If you plug this in your calculator, 5 divided by 2, you should get 2.5. And then, of course, the negative sign makes it negative distance from the origin on the x-axis. Okay, so that's one of our zeros. Now, if we have more than one zero, we just denote a little comma right here to indicate that we have more than one zero of a particular function. So where else does x equals 0, or sorry, when y equals 0? What is the x value when y equals 0? Well, we see that the y value is 0 when x equals 0 right over here at the origin. So we can go ahead and write 0 right there too. Are there any more? In fact, there's one more right here. Is when x equals 4, y value is also 0. Okay, so we have 3 x values that we know of on this function p when y equals 0. Go ahead and box that right there. Now, how can we write an equation of this? Well, remember we said it's when the y value is 0, or our function p, because we're evaluating a function p, when p equals 0. So how can we do that? Well, we have our x values when they equal 0. So we just need to know when these values equal 0. So in order to do that, let me write out our three separate points here. So x equals negative 5 over 2, x equals 0, and when x equals 4. Okay, but we want to put this in a function p where we know where these zeros are plotted. So I'm going to go ahead, I'm going to actually draw a couple of lines here to separate these guys out here. We'll be working with these three individual pieces separately. So when does the y value equal 0 here? We want to put it in terms of a function. All right. Well, all we need to do is saying when this function is equal to 0. So how do we get this side to being 0? Well, if you remember your algebra, so x equals negative, I'll just write this again down here. That's why I have this column. So x equals negative 5 over 2. We want this side of the equation to be 0. It's when our function is equal to 0, right? So x equals negative 5 over 2. How do we get the right side to being 0? Well, we can do some algebraic steps here. We can see that if we multiply by 2 on both sides here, so I'll go ahead and multiply by 2 on both sides, we can see that we can get rid of the 2's on this side. So then we should get that 2x is equal to negative 5. Okay, now we still have another step to do here. Well, is it equal to 0 yet? No, we still have one more thing to do. If we add 5 on both sides, so let's go ahead and add 5 on both sides. Add 5. We can see that we can cross these out. This turns out that this actually results to 0. And then on the left side, we have 2x plus 5 equals 0. So that's one of our 0 functions over here, is 2x plus 5 equals 0. What about this guy right here? Well, x equals 0. On the right side, we already have 0. So all we need to write here is x equals 0. And we're done with this one. Now for x equals 4, how do we get the right side to being 0? Well, all we have to do is subtract 4 from both sides. So subtract 4 from both sides. And we cross this out. We should get on the left side, x minus 4 is equal to 0. Okay. Now that we have our three pieces of information that we need for our equation, we just go ahead and simply say that our function p, and I'll write it over here, our function p, right, this is our function p, is equal to, well, we just multiply all of these guys together. So we multiply 2x plus 5, and I'll put this in parentheses, so 2x plus 5. On the left side, we have x here, so we multiply this by x. And then x minus 4 on the left side, we include that in this equation. And so we can clearly see that this is our equation right here. Now, if you want to go ahead and check your work and make sure that this equation is indeed correct, remember we said it's when the p, our function p, is equal to 0. So if you want to check your work to make sure that you set up your equation correctly, just set p equals 0. So that means when p equals 0, you basically go ahead and say that p right here, I just said that p is 0 over here is equal to whatever we have on the right side. So I'll go ahead and rewrite this, 2x plus 5, x x minus 4. Okay, and to tell where our x-intercepts are, we just say, well, since we have all of these multiplying with each other, we can go ahead and just say we can separate each branch together like this. If we separate them out and just say when they're equal to 0. So this is like doing the opposite of what we've been doing. So 2x plus 5 equals 0, x equals 0, and when x minus 4 equals 0. Since they're all multiples of each other and they equal 0, right? Because if this value equals 0, then that means when you multiply these other two guys, x minus 4 and 2x minus 5, well, anything times 0 is 0. So anything that you do here, you just want to set when this is equal to 0, right? So when x minus 4 equals 0, I forgot to write this out. Okay. And we get clearly here that x equals 4 right here. X is equal to 0 here. And then if we go ahead and do some algebra, we go ahead and get that 2x equals, now we subtract 5 from both sides. So 2x equals negative 5. And then divide 2 by both sides. We get that x is equal to negative 5 over 2. And that's what we have said over here, right? So there you go. So this is the idea or the concept of zeros of polynomials, radical expressions, exponential equations, logarithm equations, rational, any type of equations when you cross the x-axis, that's when the y value is equal to 0.